Okay, so we're going to continue with the characteristics of functions, and I left off in two different places. So I'm going to start with the increasing and decreasing tab. If you already did this one, then you can just go ahead and fast forward the video a little bit so that you get to the next tab, which is the positive. So for everyone that needs the increasing and decreasing, so I'm writing on this page right here, and increasing and decreasing we're going to just describe in one statement, and I kind of just put, increasing arrow up, decreasing arrow down. So what we're going to be doing for when we're asked for the increasing and decreasing, this describes the direction the function is going from left to right. From left to right. And that is very important concept. We read left to right. The x-axis is numbered left to right, which is why increasing and decreasing are going to follow that same idea. So I'm going to sketch a graph, and if I am going too fast, remember you can just pause the video to catch up. So I'm going to just sketch, and I'm going to make it a little off-center just so you're not used to it always being right over the origin there. And I'm going to make something like that. Okay, so this curve has parts when it's increasing and parts when it's decreasing. So I feel like just thinking about being on a roller coaster is a great way to get an understanding of the increasing and decreasing parts. So if this was the side view of a roller coaster, this right here, so again, starting at the left. So even though this arrow is going down, this is where we're starting. We're going to trace our graph. And right here, this is increasing. And it increases up until somewhere right about here. And then the graph, or our roller coaster, is decreasing. And it continues to decrease maybe until right about there. And then for the rest of this function, we are increasing. So as we go from left to right, the function is increasing up until here. It's decreasing in this part, and then it's increasing again at the end. So from left to right, what we're doing is we are going to be naming in interval notation. So I'm going to say we use interval notation, which is the same thing that we used on domain and range. So we're going to use interval notation. So what we're going to do is say that the graph was increasing until it got to this part right here, and then between here and here, which might be like, I don't know, -6 to +1, so between those two x values, our graph was decreasing, and then from 1 on for the rest of the graph, our function was again increasing. So when we do increasing and decreasing, we're following the graph from left to right, and we're describing the direction, whether the function is going up is increasing or down would be decreasing. All right, next one is the positive. So if we fold this over, positive and negative go together, but I have them on two separate tabs of our flip chart because it's a little harder to describe them all at the same time. So we're doing the positive one right now. oops, I wrote on it from the other page. So, positive describes, so this describes the x values of the function when it is above, which is why it's positive, the x-axis. So basically, what we're doing is we want to know what are the x values when the y values are positive. So the y values are positive. So what it looks like on a graph, so I'm going to sketch a graph again. And again, if I'm moving too fast, just pause so you can get yourself caught up. But if I looked at this sketch right here, and again, I'm just going to make it a little off-centered so you don't get used to seeing it all the time right there in the middle. So let's say we have this curve like this. When I'm looking for the positive areas of the graph, I want to know when is the function above the x-axis, and it is above the x-axis right here, and it's also above the x-axis over here. Now, I know that the y values are positive. The y values are above the x-axis. So what I'm saying is that they are above the x-axis between there and there, and then it is above the x-axis from there to there. So again, what we're saying is we're going to be using interval notation again. We're going to be naming the x values for when the graph is above the x-axis. So this again is also in interval notation. So that again is when we're going to say the smallest x to the largest x. Okay, so negative is extremely similar, but then it ends up being the opposite. So I'm going to go on to that page. So on the negative, oops, sorry about that, on the negative tab. So this, I'm going to write same thing. Whoops, sorry about that. All right, so this describes the x values. So we're always describing the x values of the function when it is below the x-axis. So what we're looking for here is, is we are looking for y when y is negative. So I'm going to again sketch a graph, and maybe we'll go a little crazy here. I think I'm going to go like up and down like that. So I'm looking for when the y's are negative, and the y values are negative when it's below the x-axis. So the y values are negative right there, and the y values are negative right here. And then again, we are writing in, so using interval notation. So what we're going to do is say that from here to here, the y was negative, and from here on the y is negative. So there are definitely parts of the graph, and we're going to be naming where these parts of the graph are. So from here to here, y was negative, and from there on forever, y is still negative. Okay, the last topic, I'm going to see how much I can get in. We may need to just finish it later, but the last one is end behavior. And end behavior is really just looking at the x and y signs on the graph. So this is the last page of your flip chart. So this is on end behavior. So end behavior tells the direction the function will continue to go. So, end direction, yikes, I guess my flip chart's kind of heavier on the other side now. So, end behavior is going to tell the direction that the function will continue to go. So basically what happens is that if we, once again, look at the graph, and again, if I'm going too fast, then just pause the video. But if we were to look at a graph like this, and I'm just going to go like a little bit of a zigzag kind of thing, like that, and like that. So what we're going to do is we're going to look at the ends of the graph. So by the ends of the graph, we're talking out here and out here. So those are the ends of the graph. And we can see that there are arrows on the ends. So we know that this function is going to continue to go in this direction, and this function is going to continue to go in this direction. So this is the right end, just because it's on the right side. This arrow is at the left end, and that is just because it's on the left side. And what we do is we're just going to look at what the ordered pairs are in that quadrant. Okay, so this end over here, if this graph continued to go in the direction that it's going, then x is just going to get bigger and bigger and bigger, which would be infinity. And y is just going to keep getting bigger and bigger and bigger to infinity. And the reason is because in this quadrant, the x is positive and the y is positive. So this is just going to continue to get more and more positive. All right, when we look at this quadrant over here, the x is negative and the y is positive. So what this tells me is that the x is just going to get more and more negative, and the y is going to get more and more positive. So what we say here is that x is just going to keep getting more and more negative, and the y is going to just get more and more positive. And so we use infinity because there's no ending number. We don't know where it's going to stop. We don't have a number for that anyways. So we're just going to say it's just going to keep going on forever. Now, even though we don't need them for this question, I want to go ahead and label these other two quadrants down here. If our arrow was down here, the x is positive, but the y is negative. So what we would say here, if our arrow was down in this quadrant, would be that x is getting bigger and bigger and bigger, but y is getting smaller and smaller and smaller. And then if we look over here at this quadrant, the x and the y are both negative. So if there's an arrow in this quadrant, then the x is just getting more and more negative, and the y is getting more and more negative. So that kind of sums up, that completes your flip chart. We'll talk about this more again, and then we'll start applying it to things that will make sense, like weather, stock exchange, things like that.